All right, let's go ahead and begin today's FDTD satellite applications webinar. Today, we're very happy to have Trent Davis from WFO Mount Holly, New Jersey, joining us. And the title of his presentation is The Use of Lightning and the NOAA SIMS Prob Severe Model in Tornado Detection over the Mid-Atlantic. Next slide, Trent. Just a reminder that all of these are recorded. They're posted on the visit web pages. We also are looking for speakers. So if you have any interesting topics, satellite related, that you've come across recently operationally you'd like to share with the community, please let us know, either myself, Deon Vikas, or Scott Lindstrom, and our emails are posted down here at the bottom. Next slide. Just some webinar protocol. We'll give about 20 minutes for Trent to talk. You can send questions via the go-to question or chat. At the end, we'll have a Q&A period over the phone here. We'll be done within 30 minutes. And remember, don't press hold or mute when you're not speaking. With that, I'll turn it over to Trent.
Well, thank you all very much for having me. Can you hear me okay? Just making sure.
Yes.
Okay, perfect. Okay, I will start a little bit with some background and motivation here. And so first I wanted to give you all just a little bit of background on the topography and the layout. So we're located here in kind of the center part of New Jersey. So we tend to get our fair share of severe weather, and we're kind of on the lee side of the Appalachians, so just trying to give you a frame of reference. We're not really in Tornado Alley or Dixie Alley or whatever you want to call it in the south, but we do have a lot of population in our area, so any severe weather that we do get can cause a lot of problems. There's actually about 50 million people kind of in that northeast megapolis between like DC and Boston, so it's very densely populated, and so the few tornado warnings that we do issue have a lot of impacts and a lot of people get alerts. So I wanted to provide a more discrete qualitative and quantitative way to better hone in on when we need to issue tornado warnings, but how to kind of decipher which storms are going to produce tornadoes to kind of improve our statistics and verification. Here's a look over the past 2 years of the tornado counts that we've had in our office. I'm going to point you to these 2020, 2019 lines here. So as you can see, actually I'm going to use the pointer. As you can see, we've had our 2 most active tornado years the past 2 years, so it's been very busy. And looking here in 2019, you're looking at all the tornado warning polygons we issued, and here is just another graph of that. So it's been a very active year. Even though we've had more tornado warnings, we've also had more tornadoes. Like we had 15 tornadoes in 2019. I forget the exact number. I think it was about that in 2020 as well. But our false alarm ratio and POD have pretty much held steady. I mean, there's been a little bit of improvement, but we still have, you know, any false alarm ratio is not what we want. We want to try to get rid of that. And so one of the problems is our storm structure tends to be a little more chaotic. We have multi-cell storms kind of morphing and splitting, and they're not really that well-defined supercellular structure all the time. So it can be a little bit more of a challenge in that regard, even though they are weaker tornadoes usually. Here's a look at the Lsr counts that we've had over the past 2 years. So in 2019, RCWA and Sterling had quite a few, and we had over 2,000 last year, so it's a very busy year. I think a lot of this is due to changes in social media. We're getting a lot more reports. Our accounts have grown. We've also been tapping in more to some of the utility companies and getting more of the reports that way. But I think it's also just we've had a couple pretty active years here with a lot going on, and I will let you know these are just convective LSRs. And looking at the watches, For some more background, you can see there's maybe a slight enhancement over the past 2 years in the severe thunderstorm watches here in the blue. That might be a little more noticeable than the tornado watches, but yeah, it's been a pretty busy past couple of years. So I don't know how much information you guys all know about the GLM, but I wanted to take a few moments to touch on that. So some of you probably know more about this than I do, but I found this slide really helpful from the NESDIS site here. There's a link for that. And so GLM detects little bursts of energy, mostly, I believe, in the optical light wavelength spectrum. And so it's looking at those and in 2 millisecond frames. And then it combines those into groups here. So as you can see, this is kind of more a zoomed in version. So it's combining those into groups and it lights up pixels that it will define as events. And so if this was like our grid here with these pixels would be identified as an event. And then all those together, if they occur within roughly, a defined amount of time, then it will be defined as a flash. And so all of those are kind of useful metrics that we look at here. As we know, goes east isn't looking straight down at every point in the CONUS. It's not looking down nadir. So we have this kind of parallax effect sometimes. So we are taking, and we're also, we're like decimating the data before it's disseminated down from the satellite, just because it's so much information. So we take this data and then we plot it onto a nice Cartesian grid that we have to look at in AWIPS here, which is called the ABI fixed grid. And then from there, we can define which grid points are lit up by these event and groups. And so with that, then you can get the flash extent density accounts. And then we sum those over like a minute or 5 minutes. We can change the refresh rate we also get with that. And so with that, I'll show you in this figure, you're looking at those, the density of these. And I believe I had this on 5 minutes time with 1 minute refresh rate. So you're looking at the summed flash extent density counts, which is basically like how many flash channels are crossing those grid points in the 5 minutes, and then we're updating every minute. And so you're also looking at the 2 mesoscale sectors. And this was the severe weather event in the Southeast a couple of days ago. And I just thought it was really cool. And first major severe weather event probably of this year. So that's kind of what it looks like in real time for us as warning forecasters. So the second part of kind of the background of my research, I wanted to survey NWS forecasters, mostly those who have and are issuing warnings. And I wanted to see what they're looking at when they issue warnings. And so this is the survey I sent out the end of last year. And I got a really good turnout here. So the first question I asked was, I asked them to rank the guidance used in their convective warning decision making. And I was mostly trying to gauge how aware forecasters are of Prob Severe / Prob Tor and also GLM. And I guess you could kind of lump the like Earth ground networks of lightning also with GLM. And so the first choice here is radar. That wasn't really surprising to me. A couple people had it as their second choice because they were like in portions of Alaska or the West, and they really didn't have very good radar coverage. What's more interesting is the from second to sixth choice, that is a lot more variable here. So some people are looking at satellite, and that could be anywhere from like water vapor to visible. And then the GLM stuff, I will add actually their GLM only uses info, I believe, from goes east at this point. They're maybe going to add goes west, but at this point, I believe it's just goes east. And then there's some other like LSRs and MRMS products. So pretty much everybody has their own way of looking at subsequential information and maybe certain information is better in different areas of the country. And so for the second and third question, I asked down here in the bottom, how often do you utilize Prob Severe and Prob Tor in the tornado warning decision-making process? And if they're unfamiliar, I asked them to select 5. I'm sorry, I asked them to select 1, 5 being that you use it all the time. So this was similar across the regions of the like southern region, eastern region. That didn't really seem to vary. And the results kind of solidified what I thought was that people are kind of aware of the products, but they don't exactly know what they're looking at or how to use it. It's just something that they kind of have heard about, maybe use every once in a while. Looking at the lightning products with GLM and some of the ground networks, I was happy to see a lot of people look at these pretty often, but then there are some people that don't really know how to use that, and they don't know how to interpret the results. And so one of the quotes that I had that basically summed this up best, even though I had several people mention this, they said if I became more comfortable with these products, I would try to use them more. And also I mentioned I had 159 responses, so I was very pleased with that. I didn't expect that many people to reply, and we had 64 individual NWS offices or in a couple national centers. We had people from SPC, the Aviation Weather Center, and WPC respond. Looking at the Prob Severe component of the survey, I wanted to share some of the quotes here. I'm not going to read through all of these, but if you're interested, feel free to go back to the presentation. So people mentioned that, you know, it may not perform as well in my region of the country, but I kind of mentally look at things to calculate lightning jumps. People said maybe GLM could be useful for IDSS. Maybe it's good as an SA tool, but I don't really know how to quantify and get like solid results from it. People talked about the percentages not really being that meaningful to them. And that's something I've kind of noticed at our office too. And occasionally people had said they noticed trends, and then that kind of reinforces their decision. And that's very similar to what I've noticed here at our office. So I kind of wanted to better quantify those trends so we know what we're looking for. With the lightning or GLM component of the survey, there are some of the quotes. Again, people talked about trying to figure out what a lightning jump was. Lightning helped with some of the IDSS. In the summertime, it's kind of helped back up their radar decision. So if they were thinking about issuing a warning from radar, it helped them do that. And let's see what was. One of the terms I liked was they used the flash products kind of as nudgers to issue a warning. And so that was a big takeaway I got from the survey. And so to summarize it in 3 points here, there are similar feelings across the surveyed forecasters that the products help tip the scale, but they should only be used as a tool alongside radar. Spatial variability is a factor. These tools can help give you more confidence in areas where radar coverage is lacking, which is probably more of a case in the Western US. And also people requested that we have better training for these tools so they know what to look at from GLM, maybe even other satellite components, and especially with Prob Severe, what values should we be looking at? And I will mention Prob Severe, it uses a lot of components from satellite in conjunction with the lightning. So if you're not quite familiar with what Prob Severe uses, that maybe can help you a little bit. The component of the research that I did here in my investigation centered over our CWA was I started with the 15 tornado events that we had in 2019. And I just went with those 15 and wanted to see how able to be tracked they were, which that was a big limiting factor. Again, it's very hard to track storms when they're not discrete. They're moving and combining with other storms. We had a lot of QLCS events, and a couple of the tornadoes were with tropical events, so that made it kind of hard to track the individual storm associated with that tornado. So once I got the data, thanks to Michael and John at NOAA Sims up in Wisconsin for the data, I was able to use 4 cases that were trackable enough when the tornado occurred, and then I was able to look at the information before and discretely associate it with the individual storms. Then I also looked at 2 non-tornado cases that occurred on the same days that we had tornadoes, and the storms otherwise looked pretty similar on radar, to see if we could tease out any differences amongst those. So in total, I had 6 storms that I deeply looked into in this investigation. Following a method from Chris Schultz here in this paper, I calculated the lightning jumps from the ground flash rate from ENTI, and then I also wanted to look at, which I believe this is a new process, I wanted to look at the changes in the flash channel jumps, flash channel density jumps, not just the raw flash rate. And so this is the method here. You start with either your flash rate or your flash channel number, and then you kind of smooth that out over, this period was like a 10 time step period, so you smooth that out. And then this step then is a second smoothing, so you're not looking at it as quite as jagged of a process. And then you calculate these the standard deviations from that in each time step, and then you're comparing that to time steps previous. And then in the end, we define, as he did in his paper, we define lightning jumps as when that standard deviation is greater than 2 sigma. And I did the same thing looking at the flash channel densities as well. And with that, I'll show you some of the results. So the most significant tornado in terms of damage in 2019 was one that occurred just south of Reading here in Morgantown, Pennsylvania. So Philadelphia is right here. It's just up the Pennsylvania Turnpike, closer to the Alleghenies. And this storm tracked from near State College, Pennsylvania, and it gradually strengthened as it started to turn right and move southeast into our CWA. So this is over the time frame of the Prob severe defined storm that it tracked. And so I'm plotting the Prob severe value here in blue, which is a percentage value. It's like a % chance that it thinks the storm is going to be severe, taking into effect radar, the satellites, trends, some data from RAP, and also from radar. And then they added a new component, which is Improbtor. And so I initially wasn't going to look at that, but I decided just to look at that value as well. And that's plotted in black. In the middle here, I am plotting the flash jumps. So we're looking at the raw flash rate in blue, and in black here, we're looking at the flash channel density. They both go at the same axis. And I plotted the areas in purple where we have the raw flash rate jumping greater than 2 sigma. So you can see there's a lot of periods where they're short-lived, but the flash rate is kind of spiking. The flash channel density is, the amplitude is a little bit more reduced, but we see this general trend with an increase in the flash activity and then kind of a decrease. And then I'll also mention the tornado is plotted in this gray area, and the individual tornado warnings that were issued are in the pink here. In the very bottom, I have the flash channel densities, just not the standard deviation, the raw number in black, and the flash rate from ENTI in red, and the GLM detected flash rate here in blue. So you can see there's a little bit of discrepancy between the networks, but if you look at it, you can kind of get the same trends from this. And you, even with this, you can see further how you have the increase in activity, a decrease, and then a ramp up right as the tornado is occurring. And this is a trend I saw in a couple of the other cases. But first I want to do a quick radar loop of the storm. So you can see right here, and then right there is when the tornado occurred. I'll run through it one more time. You can see it was subtly a right moving storm, and it caused quite a bit of damage. It was an EF2. I actually got to go out and survey this. It was one of the first storms that I surveyed, and it was pretty impactful. Here's a quick video of that storm, just because everybody likes to look at tornadoes. And so this started in Lancaster County, which is adjacent to Berks County, and then it hits this turkey farm here just in a second. And right after that, yeah, right there is basically the start point of the tornado. And thankfully, nobody was hurt in this tornado. So we were very lucky because it did destroy a few homes. And it was very interesting seeing the swirling in the field here of the crops. And then it moved into our part of Berks County there. With that, I will move on. Another storm that happened on the same day was up in northern New Jersey in Stanhope in Sussex County. And so the graph is the same here, and this is about when the tornado occurred. And this time the tornado was much shorter lived, so it's just a solid black line. But you can see the same trend here where you have an increase in lightning activity, a decrease, and then it definitely, down here it's even more noticeable where that lightning activity increases right leading up to the tornado. And you can see then we issued the 1 tornado warning once we got word of that. So similar trends here. There are a few differences, but again, that's kind of a takeaway. And another storm that we had was a day we didn't really expect tornadoes because there was high shear but very low cape this day. And so this happened just a couple miles from where I live, and our office is right here in Mount Holly, so it's easily surveyable for us. Lightning activity was very decreased, as I mentioned, because cape was very low this day. But I went ahead and plotted it anyway because the storm remained pretty discrete. And so you can see, hard to tease out results from this, but again, even in the storm cycling, there is kind of that like the low point in the middle there. Hard to really get results from that one. Here's a quick video of that tornado. And as small as it was, because it was more of like a landspout tornado, it did flip this car over. So it was quite impressive, had some roof damage to this warehouse right by that parking lot. Thankfully, nobody was injured in this storm either. So then to look at from the 4 storms that I tracked, I wanted to kind of summarize the results. So even though the caseload is relatively small, and I hope to add more cases, I just wanted to give you the range and what I looked at. So we have for the flash rates, tends to kind of sit right around 20, 25 flashes per minute as the max value you see before a tornado warning or a tornado occurs. Sorry. The flash channel densities is kind of anywhere from 50 to 75 as the flash channels. The maximum lightning jumps. So again, this is the rate, the change in the flash rate, not just the max flash rate. So that's anywhere from like 5 to 10, and then the flash channel densities we saw kind of right around 30 with some higher and lower amounts. The maximum lightning jump times, that's very variable. Some cases we got a lot of lead time, some we didn't. And the Prob severe products, they tended to range from 80 to 100%. And then this was the Mount Laurel tornado where it was relatively weak. So I will first look at the two cases that didn't produce tornadoes on days. So this was that Morgantown tornado, and then I'll summarize all the results. So in this case, again, we had a couple periods with the 2 sigma lightning jumps, but no tornadoes or tornado warnings. This was when we saw the first damage, more severe thunderstorm damage. So one takeaway I see with this is there's the trends are a little bit more smoothed out. They're not quite as chaotic as this tornadic storm. Similar with the case that occurred, so this was a Stanhope tornado, and then this case that also occurred on the next day, May 29th. So environments were similar both of these days. It didn't quite have the lightning activity that we saw in these 2 cases. Although we did have a noticeable trend here with an increase and then a decrease in activity and then another increase, which was interesting. And also the Prob severe values didn't really climb quite as high in this case. And that's something I noticed on more in other days, but these 2 were the most noticeable. So some conclusions here as I wrap up. If you average the lead time that I observed in these 4 cases, you get it roughly around 26.5 minutes. So any lead time help, we'll take what we can get. And so that's something that I'm hoping to add more cases to get a better statistical number here. The chaotic cell mode that we observe here in the eastern US made it difficult to be able to use all 15 of those cases, but we had a good data set from 2020, so I'm looking to add that in. And I might also be doing some work here with the State College and Albany CWAs and working with those offices. And so that's future work I want to look at. Maybe I will try to develop my algorithm a little bit better to track storms even if their IDs are changing. So try to add some more cases, but I want to be careful with that, and I don't want to take into account storms that are really changing in size and noticeably not the same identifiable cell. And the 3 takeaways from this would be: number 1, Prob severe and lightning are useful in warning operations, but as number 2, you should look at more of the trends and compare on the same day, not comparing a June 25th number to a May 25th number. You want to look at the trends and compare and contrast on that day. And with this, you could provide longer lead times than just looking at radar alone, but this should be used as a tool in conjunction with radar. And if any forecasters are on this call, if you want to look at the real-time Prob severe data, you can go to the website here, and it will plot out these nice little time series graphs. And right here in the upper right plot, you can look at the total flash rate and the lightning jump. So it'll plot that value as the sigma level here. So you don't have to do any calculations. And this is something I like to keep up when I'm working radar, just to say, hey, this storm is it's undergoing a lightning increase. Then if the jump does increase up closer to 2 sigma, then I more consider issuing a warning after that point. So it's something that I've been telling people at our office to start using. And I would say it's definitely helped us quite a few times. And here's my acknowledgments. So with that, I will wrap up and take any questions.
Thank you, Trent. At this point, we'll take questions for any questions on this great presentation. You can either post them in the question dialog box on the GoToWebinar, or I will go ahead and unmute everybody so you can speak up on the phone as well. I do see a question from Anita. Says that she does use that while monitoring radar or as the mesoanalyst.
That's a good point. I should mention, sometimes if you are too busy, it's a good thing if you have a mesoanalyst, they can keep on tabs with it.
Okay, Scott Lindstrom, you have a question. Go ahead.
I guess Thanks for the presentation. My question is on, you noted that the people who replied to the survey said, well, if I knew more about this product, I'd be more comfortable using it. So have you created training in the office? Or is there training in your office, or do you have, or are you using training from the LMS and the center, or how do you think that's the way to train the people?
That's a good question. Let's see, which slide was that? So I just presented this at we had our office spring workshop. And so I think I'm working with my Sue to maybe develop a new training. We tried to add as much as we could from the CLC as our spring training plan that we have, which was just released. But yeah, otherwise I tried to touch on this and discuss it at our spring workshop. And so yeah, we'll see how things go from there.
And my other question was it was my understanding that in AWIPS, I mean, the Prob Severe is in AWIPS under the MRMS now.
Correct, yes.
So when you look at it, can you also bring up all those different parameters that you can see in the
yes.
version? So if you sample it, if you sample Prob Severe in the MRMS, can you also see all the different components that are going into the Prob Severe, like the cooling rate and
yes.
those different things?
Okay, let me switch presentations 1 second. I have an example of that, which is very nice. Yeah, I kept it in the office one, but this one, I think it was in here. Nope. Which one was it? I know I have it in here. But yeah, you can, basically they gave me an archived version that had a little bit more data than what we see in real time, but
I know there's the problem of making meteorograms out of the data.
Yes, I had to figure out how to do that. And now going in the future, it's a little easier because I can just take note of what the ID was, because the data they give me is like a list for the entire CONUS. So there's like huge amounts of data, and it made it a little bit hard to sift through. Yes, right here. So if I can zoom in on this, it spits out, you can, so you can't really read it, but it spits out all of that information if you sample a storm. So this is like the layout you would look at, and then it kind of color codes. You can change that curve, but so it's just a good way to kind of triage storms in real time. I like to overlay this on radar too. It's very helpful.
Yeah, that's a lot of storms to keep track of in one day.
Yes. Much.
Thanks.
Okay, any other questions for Trent? We have a question from Patrick Dills. How do you define flash channel density?
Okay, yeah, good question. Let me go to that slide. So from my understanding, I am not a complete expert in this, so I may be speaking incorrectly on parts of this, but so say this was your flash, and then GLM is looking at these individual components. Lightning, it kind of moves in little segments, so each one of those releases very high frequency radiation. So that is largely in the visible light spectrum. So so basically GLM is looking at those little bursts of energy, and it can look at it fast enough, like if we had a video and slowed it down. And so it'll light up and say, okay, there was an event that happens here, like on this pixel, and it's looking, has its resolution. So it's looking at that, and then within the span of like, I think a minute is the fastest time resolution you can use. So if 5 different parts of flash channels, and it could be the same flash, a different piece of the channel broke off and went over here, you're just summing up how many of those happen in whatever time frame. And then unfortunately we can't look at it in the vertical dimension, so it's summing that all the way down in that vertical column. There's some channels that could be missed if you have like very deep convection and you're having channels at the very bottom of the storm, but they're working on ways to hopefully try to get around that. But largely that's what we're looking at here.
Okay, great. We have a couple other questions that have come in. I'll start with Sheldon Cusselson. Did you have a chance to look at the August 2020 case ahead of ICE as the tropical system was coming north along the mid-Atlantic coast?
Good question. I believe I did look at it. I can't remember why I couldn't use it. But if it did produce a tornado, I looked at it, I remember. I think it might have just not been discrete enough.
Okay. Another question from Joe Phillips. Do you know if Prob Severe has different criteria for marine thunderstorms? SMW criteria is defined from severe criteria.
Interesting.
Or different, sorry. SMW criteria is different from severe criteria.
I don't know exactly. I'm pretty sure, I want to say I'm like 90% sure it doesn't. It's mostly just catered for it.
Yeah, this is Scott. It doesn't.
Okay, yeah. I was gonna say I don't think it does. Yeah.
Okay, and I see a comment or question from Anita. Prob Severe was designed as a method to determine in the growth cycle of the storm, the percentage chance that a storm would be severe in the next 30 minutes, but I find that some METs use this much longer into the storm life cycle or rely on it too much when the value may be compromised due to lack of satellite input.
Yeah, that's a good point. Yeah, it's once the storm is already mature, especially if you're getting reports from it, then it is probably more helpful if you're initially thinking about warning on it versus like, oh, well, it jumped down a little bit, so I should probably not issue an SVS or I should cancel it. At that point, hopefully you're getting some LSRs and you're able to combine those with radar trends you're looking at. That's a very good point.
Okay, thanks. And let's see. And Scott just added Prob Severe is the probability in the next 60 minutes, not 30.
60 minutes.
Yeah, I'll just add one comment myself. This lends itself very well to data fusion, and I've been involved with data fusion training for the updated Walk Severe course, where you look at lightning trends in addition to satellite storm signatures that may be seen, along with radar, environmental data, all these things together. And in the exercise that I looked at, for data fusion, closest radar was down. There were some issues with the Earth network's lightning data all around the time of a tornado that was occurring. So it was interesting to use what available data was there, and looking at various signatures from satellite that helped. So that training will be out there very soon, just to point that out, some data fusion, since it lends itself very good to that as well. Any other final questions or comments for Trent? Okay, well, hearing none, we want to thank Trent for a great presentation, and the recording of this will be posted on the visit pages within the next couple hours. And our next webinar is on April 7th, so be watching for advertisement on that. Thanks, everybody. Have a great day.
Thanks.